our new course on C programming. This is an introductory course to C programming. The C programming language has been around for over 40 years, and there's a reason for that. It is a structured programming language that many existing programming languages are based on in one or more ways. So what are we going to learn? The course is divided into 5 units. In the first unit, we're going to install the GNU C compiler and also a program called Brackets that I'm going to use. You don't have to use Brackets, but any text editor will work just fine. C program source files are just text files. We'll talk about the basic syntax of C as we develop a simple hello world program. And then we'll talk about the primitive types in the language. Things like chars and ints and shorts and longs and floats and doubles and so forth. And we'll also talk about using what's called the size of operator to determine the size of the memory that we've allocated using those types. We'll wind up the first unit talking about the arithmetic operators in the C programming languages, the operator that allows us to do arithmetic. In the next unit, we'll begin with a discussion of conditional expressions, greater than, less than, equal to, and then talk about Boolean operators, and, or, and not. Then we'll go into decision making, which relies on those conditional expressions, if else, if else if, and we'll have a demo on all of that. The next thing we'll do is talk about arrays, which are collections of data all having the same type that we can access using an index into the array. And then finally in Unit 2, we'll introduce one of the most important parts of the C language, and that is pointers. Unit 3 begins with a discussion of loops, the various kinds of loops in C. We'll talk about functions. We will talk about the difference between passing a value to a function and passing a pointer to that value, to that function, and I'll give you a link to the GNU C functions, the C compiler functions in the GNU C compiler. Finally, we'll talk about getting input into a program and using a function called scanf to scan for input from the user. Unit 4 begins with a discussion of something called pointer arithmetic, which is a way of using pointers to find places in memory that are offset from other places in memory. Finally, in Unit 4, we'll begin wrapping up our discussion of C syntax with the idea of a structure, which is a collection of data given variable names that we can access from the structure using either a pointer notation or a dot notation. We'll talk about the difference between stack memory and heap memory, and we'll show how to dynamically allocate structured data on the heap so that we can build larger data structures in Unit 5. Unit 5 talks about making a stack and then making a structure called a linked list, which links various structures on the heap using pointers. So by introducing these ideas in this way, I'm giving you an introduction to the C programming language that will help you understand everything there is in the C language and allow you to continue your studies of C and really any modern programming language based on the ideas that you learn in this course. This course on programming in C. For this course, you're going to need a C compiler. You don't need to have a full-blown IDE. In fact, in this course, I'm not going to use a full-blown IDE. I'm going to use the GNU C compiler. This is a compiler that is available to use on Windows, on Linux, on Mac OS X, and so forth. So any system you have, you will be able to find a GCC or GNU C compiler. So where do you find this information? Well, first of all, you can look up at gcc.gnu.org all the information on the GNU C compiler collection. So you can find a distribution for your system right here. If you are on Windows, you should look at the mingw.org page, MinGW. This is the Min GNU compiler for Windows, the minimalist GNU for Windows. And this will give you a Unix-like environment with some basic Unix commands so that you can follow along in this course running on Windows and program in C right along with us. So go ahead and get and download, follow the directions for opening and installing a GNU C compiler on your system. Now, if you do have a Mac, if you're programming on a Mac, all you really need to do is download and install, and this will take some time, the free Xcode suite of tools. And this will give you a couple of different C compilers. But C is a very standard interface, and programming in C, compiling and linking is all very standard no matter what system you're running on. So go ahead and do that, and I'll see you back in the next lesson. And so you'll need a text editor. Now on Windows you can use Notepad or TextEdit or something like that. Really though, you want something that has some at least minimal syntax highlighting for your text files that you're going to program in C. So what I'm going to use is a program called Brackets. This is a text editor, and it was designed for the web, but it also understands C as far as syntax highlighting. So I'm going to use Brackets. It is available for Windows and Mac OS X, and I believe for Linux as well. You can find it here at brackets.io. So what we're going to do is I have an empty C, actually I have no program here. I have a Unit 1 folder created, and I'm going to create a new program in Brackets. So File, New. This gives us an untitled program. Now I can save it, and I should save it immediately with a name. So I'm just going to say File, Save, or Save As. And in Unit Run, I'm going to create a file called Hello. Now I'm going to give it a C extension. This is usual for a C program. So hello.c, and now we'll save the file, and we have nothing at all, but we have a formatted C program that we can edit here in Brackets. So the first thing I'm going to do, and this, if you've never programmed in C or any other C-like language, this will look a little weird, but I'm going to type include bracket stdio.h bracket. Now that says include something out of the standard IO library. Now what I want to do is create a minimalist C program, a hello world program. So the next thing I'm going to do, and again, don't worry about all of this, what I'm going to type, just kind of let it flow, and we'll talk about all of these things that I'm about to type in here a little bit later. So the first thing is int main int argc argc car star argv argv, and then square braces, and there we go, and then that. So this is a main function declaration. So then I'm going to tell it to print something. So printf, and again, don't worry about why it has an F at the end. Very shortly we'll learn why. So now I'm just going to print out hello world, like that. Very typical first program, and then I'm going to close the curly braces. So let's talk a little bit about what's going on here. First of all, this printf hello world, if you've worked with any other programming languages before, you might recognize this as being something called a function call. Printf is a function, and we're telling it what to print as a string. So the string here is hello world, and it's encased in double quotes. And then the argument to the function is encased in a pair of parentheses, and then the entire function call, the entire statement, is terminated by a semicolon. And in C, every statement must be terminated by a semicolon. Now, what's going on with the curly braces? The curly braces group a collection of statements that we want to execute as a unit in some way. So this is a function declaration. This function is called main, and it is the entry point of any C program. And in this case, main is returning an integer, and it has two parameters, an integer parameter called argc, and a character parameter of some kind here. This is actually a pointer to a character, and it is called argv. And then there's these strange square brackets here that we'll talk about in a little bit. But it has two parameters called argc and argv. And so when main executes, it will return an integer. And if it executes, by the way, if it executes successfully, it will return a 0 to the operating system. So this program should go into main and call the printf function, printing out hello world. So let's see if that's the case. Now, to compile the program, I need to go into the Unit 1 folder, and I'm going to do that now. And here I am at the command line. So let's just cd, sorry about that, Unit 1, and here I am. And now I can very simply compile with the GNU C compiler. I can simply compile our hello program. So let's make sure it's there. So ls, and here we have hello.c. I have a CM project file here, but ignore that. Hello.c. And now I'm just going to compile and link the program in one step by typing make hello. Now, I'm not going to type the extension, the .c. What we are making is an executable program called hello. So let's do that, and it does that. Now, it says undefined symbols for architecture, x86 64-bit, main referenced from, main executable, symbols not found. So let's look at this program because we did get an error. Let's look at it again. Alright, so normally in C, white space like this is ignored, but this is an exception. The parameter list for a function name needs to not have a space before it. So just as we have printf here, if we did this, that would be an error. So here we have main with no space between the end of main and the beginning of the parameter list. I really don't know why I typed it that way, but we're going to resave it and rerun it, or rerun the make on that, the make utility, and we get the prompt right back. And now we can just, on a Unix system like Mac OS X or Linux or something like that, we can resolve to the current working directory or this folder and type hello and run the program. And it says hello world here and gives us our prompt back. So we really need to include carriage return after this hello world because we don't want this prompt to be coming up on the same line as our running program. So now let's put a new line at the end of this. Put a backslash and an N. This is the new line character in a printf statement. So let's go ahead and save that and see if we got properly formatted output. So since we've saved it, we need to compile and link it again. So we're going to make hello again, and now we can run /hello. And there we go, hello world, new line, and now the prompt again. Scalar types. Primitive types are the types given to us by the language. So in C, we have basically two kinds of primitive types. We have integer types, we'll talk about characters here in a second, and floating point or real number types. So what are the integer types? Well, char may be interpreted as either a character or a very tiny integer. A short is a small integer. An int is an integer, kind of a general purpose type integer. A long is a big integer, and a long is a little bit odd. It is at least as big as a long. On most systems, it's the same size as a long. The floating point types, or the real number types, are float. This is a basic floating point number, a real. A double is a big, so to speak, floating point number. It could also be a very small floating point number, depending on how many decimals of precision you're carrying it out to. And then a long double, which is a really big, or extremely small, if you will, floating point number. So how do we declare a variable? Well, we declare a variable by first supplying the type, then the name, then optionally assigning it a value. So we have a length here. It is an integer, and it is not assigned a value. This is fine. We have a short. It is called width, and it has a value assigned to it, the number 2. And it being a short, it is an integer type containing the number 2. We have a character called letter, and it's been assigned the value of the character capital A. We could also assign letter an integer value, like 65, which is the ASCII value of the character capital A, for instance. Variables must, however, be assigned a value before they are used in C. So there needs to be an assignment someplace, either in the declaration itself or sometime later before we actually try to take the value that's in that variable. Talking about sign, there are really two types of sign in a programming language. There is positive and negative. Each type that we talked about may be signed, which is the default, or unsigned. Signed simply means that the number can take either a positive, a negative, or 0 value. Unsigned means that only positive values and 0 may be stored in that type. So to mark a type as unsigned, we use the keyword unsigned. So to create a number called my number, which is an integer, we say unsigned int my number. Now unsigned comes before the name of the type. So we have unsigned int my number, not int unsigned my number. So the question is, how big? So I said that cars were either very tiny ints or characters. Shorts were bigger than that, and ints were bigger than that, and so forth. Each variable type is allocated a number of bytes in which its value will be stored. So to find the maximum unsigned value of a number, we multiply the number of bytes that that number gets stored in by 8 to get the number of bits. Then we raise 2 to whatever that number is. So we take 2 to the bits power and subtract 1. So that gives us the maximum unsigned value of one of these types. So have an example. I will tell you here that the maximum, or the number of bytes in which a short is stored, is 2. So we take 2 to the 8th, or 2 times 8 to get 16. That gives us the number of bits. We raise 2 to the 16th power. That's 65,536, and we subtract 1. So that gives us 65,535. So the range of an unsigned short is 0 to 65,535. So the min and max of a signed value are a little bit different, but not really all that difficult. The highest order bit, the leftmost bit, stores the signed flag, what is called the signed flag, for a number. So the minimum value is negative, the quantity 2, to the number of bits minus 1. The maximum value is 2 to the number of bits minus 1 minus 1. So let's take an example of that. Again, a short is stored in 8 bytes. So, 2 bytes, 16 bits. So the minimum is negative 2 to the quantity 16 minus 1, which is equal to negative 2 to the 15, which is negative 32,768. That is the minimum value. The maximum positive value is 2 to the 15th minus 1, which is 32,767. So this is how we calculate the maximum and minimum values of signed and unsigned numbers given their type. How do we get the number of bytes? Well, we have a function. It's called size of, and we pass it the type. So size of type is going to return the number of bytes for that type, and it will return it as a type unsigned long. So here we have car size, which is declared to be of type unsigned long, and it's assigned the value size of car. Now we can also use size of with a variable name. So if we, for example, make a value days as a short, then we can say unsigned long day size is size of days, and this will return us 2, the number of bytes in a lot of libraries hanging out in C's standard libraries. So how do you know what a function does? Well, thankfully, if you're on a Unix-like system, Linux or Mac OS X, for example, you have the man function, the manual command. So running man is pretty simple. We just type man. Now we can get the manual instructions by typing man. And this will give us the command and a synopsis and a description and a lot of different information. Now there are several different chapters or sections of the manual pages. We can get out of this by typing Q, by the way. And all of the C manual functions are contained in Unit 3 or Section 3. So if we wanted to know, for example, some information about the printf function, we can type man 3 for the section, the C language section, and then printf, and it will give us the information for printf in section 3. There are a bunch of functions in the printf library or printf specification. It is in the standard C library, and it says here that in order to use this function we must include stdio.h, just as we've done so far at the top of all of our source files. So it tells us printf and then a constant char star restrict format and then ... All right, so what does all of that mean? Well, we can read, and you should read, the description in this man page. By the way, if you don't have man on your system, you can Google this information. You could just say C printf and search for that on the internet, and it's all out there. But, for instance, if we wanted to know something about the format type characters in printf, we could see that in order to get back, for example, a unsigned long, we would use L and tell it that it was unsigned, U. So LU would give us back a formatted unsigned long, and we're going to see how to do that here, or why we might want to do that here as we look at the next piece of source code. So we'll quit to get out of this. I would really highly suggest that you read about the printf function, either by typing man3 printf and reading the manual documentation, or searching printf on the internet. So now, here we go. We have a main function again. We've included standardio.h. By the way, this is the syntax in C for a single line comment, 2 slashes, and then whatever we want to comment. Print the number of bytes used by a C primitive type. So here's our main function, and all we're doing here is doing a printf, and then notice this. This is a format specifier, %LU, and this will be replaced by whatever we place out here in the following parameter list. So notice that I've typed car, a colon, a space, %LU, and then a new line, and I've given it size of car. So I want to know how many bytes a character is. So I get that as an unsigned integer, and it will be replaced in this string into the position occupied by this %LU, long unsigned. I get the size of a short, an int, a long, a float, a double, and a long double. What do I want to know from this program? I want to know how many bytes is occupied by a car, a short, an int, a long, a float, a double, and a long double. So this should do what I need it to do. Let's check it out. In the terminal, I'm going to make types, which is the name of the program, and it's up to date, and then I'm just going to execute it. Types. So we find out here that a car is 1 byte, a short is 2 bytes, which we already knew. An int, notice, is 4 bytes. So that will be 4 times 8 is 32, 2 to the 32 minus 1 for the maximum unsigned int, and 2 to the 31st, negative 2 to the 31st through 2 to the 31st minus 1 for a signed int. A long is 8. Notice here that a long is at least as large as a long, but in this case a long is also 8. A float is 4 bytes, a double is 8 bytes, and a long double is very big indeed, a 16-byte number. Alright, so that is how we find out how many bytes are in each of these types by using the size of function and then passing it back into a formatted long integer in a printf string. Hi, welcome back. Now we're going to begin to talk about operators. Operators are like arithmetic operators where we add, subtract, multiply, and divide numbers. There are other operators in C, but to begin with, we're just going to talk about the simple arithmetic operators in this demo. And then in the next couple of demos, we'll extend that a little bit. So now in our main function, I've assigned car, a letter, equal to the character A. When we have a string, we use double quotes. When we have a single character, we use single quotes like this. I'll use that in the next demo maybe. And then we have integers A and B assigned the numbers an integer 3 and an integer 5. And then we have an integer result. So in the first part of this program, and there are a lot of other statements here that I'm not going to talk about right now, we're going to add A and B and print out the result. The way we do that is assign result the value of A plus B, plus being the operator here. And then we're printing out an integer plus an integer is equal to an integer and a new line. This first integer, %d, will be replaced by A. By the way, D here in the format specifier stands for decimal or digit. So D will be replaced by A. This %d will be replaced by whatever is in B. And then result will be replacing this %d. So A plus B equals, hopefully, 8. Then we'll have multiplying A plus B and print the result. Same way. We'll subtract B from A and print the result. And then we'll divide A by B and print the result. So that's the first part of our program. Let's go ahead and make the program. Make arithmetic. And then we will run it. And we get 3 plus 5 is equal to 8. 3 times 5 is 15. 3 minus 5 is negative 2. And 3 divided by 5 is not equal to 0. So what went wrong? Well, for the first idea of what went wrong here, remember that A and B are both integers here. So I have a comment, well, that didn't work very well. Let's try that. And result is also an integer. Let's try assigning A divided by B to a floating point number and print that and see if that works. So good try, good theory. Let's see if it works. So once again, we make the program and run it. And well, we did get a floating point number. We got 6 digits of precision, but it's still 0. So maybe if we divide an integer by an integer, we always get whatever that integer, the result of the integer division would be. 3 divided by 5 is 0.6. So something is being sawed off here. Maybe A and B, or the things we're dividing, should both be floats as well. So let's try that. So we can't just reassign A and B to be floats, but what we can do is create a float c and a float d and make quotient c divided by d. And if we print that, we should be okay. I'm going to talk more on this later as to why this has to happen and some other things that we might be able to do to help us with this kind of calculation. But again, we'll make arithmetic and run it, and we see that 3.0, the floating point, divided by 5 as a floating point, is equal to 0.6. Okay, so we're okay. But I'm not telling you how to format these a little bit better. I'm not telling you what really is going on under the hood with integer division and floating point division and how to get things to happen. We're just saying this is how we get a real result. So for now, in order to get a floating point result, we need to divide a floating point by a floating point. All right. So now let's go on just a little bit more. There is a unary minus operator, a equal negative a, and if we print that, we should get negative 3 out. But now watch. If a is negative a, then a has been assigned the value negative 3. What we want here is negative 3 is minus 3. So if a is minus 3, we need to minus a and then a. And then we reset the value of a here. So we're going to stop here, but before we do, I'll just go ahead and run that again. We'll make it. Oops, I forgot to save. Let's save this file, and then we'll make it again and run it. And now if we run it, we see negative 3 is minus 3. All right, so more to come. Thank you very much. Cut assignment operators. These are operators that both perform an operation and assign at the same time. So for example, instead of saying a equal a plus 3, we can say a plus equals 3. And this says the same thing. This says a is equal to a plus 3. And so if a is 3, which it currently is, a is now 6. B minus equals 2 is b is currently 5, b is now 3, because this says b equals b minus 2. So now we print out a and b, and now we can proceed to multiplication and division. C and d are both floats, so we should be okay. C C equals c times 2, c is now 6, and d is equal to d divided by 2. D is now 2.5 because D started out as 5 and C started out as 3. So we print both of those and let's see what happens. So let's go ahead and make and execute the program again, and we see a equals 6, and we'll do this for comparison. A is equal to 6, B is equal to 3, and that's right. C is equal to 6, and D is equal to 2.5, and that is correct. So these are the shortcut assignment operators. So we can assign and perform an operation at the same time. Now we're going to go back and assign the value of 1 to A and 0 to B to prepare for what we're going to do next. So the increment and decrement operators are also like adding and subtraction, except they are unary operators. In other words, they perform their operation on their argument immediately. So first of all, we have a plus plus. So a is now equal to 2. So let's just see if that is currently true. Let's do that. So a is equal to 2, b is equal to 0. That's good. So now let's do b equals a plus plus. So if a is 2, then a becomes 3, but what is b? We expect b to also be 3, but let's find out. The increment and decrement operators have two forms, both the prefix and the postfix form. So a did get assigned the value of 3, but b is still 2. So let's see why. A is incremented, but before it is incremented, B is assigned the value of A. In order to increment A and assign that incremented value to B, we need to put the plus plus before, prefixed to A. So now A is 3 before this statement. Plus plus A makes A 4, but it also assigns B the value of 4. So let's see if that works, and it should. We should see that A is equal to 4 and B is equal to 4. And we do. So you see it makes a difference whether we have the plus plus or minus minus before the value or after the value. So let's look at that decrementing operator. B equals to minus minus A. We should have no surprises here. Minus minus A makes A 3, but B should still be 4. And B equals, A minus minus is that case. B equals minus minus A. Both of these values should now be 2. So let's go ahead and run this for the increment and decrement. And we see that A is 3, B is still 4 in the case of B equals A minus minus, and A is 2, B is 2 in the case of B equals minus minus A. So please understand how these increment and decrement operators work in both their prefix and postfix form. So now for the last demonstration, we had, remember at the top of the file, we had a car letter declared as A. So here we're going to increment letter plus plus. And now we'll print out the value of letter. But we're going to print it out both as a character with %C and as a number, as an integer with %D, passing it both times letter. So this kind of says, well, if this is an A, if I increment an A, a capital A, I should get a capital B. That's what that kind of says, and that is indeed what it says. But we get it because we formatted the printout. B is ASCII 66. We format it as both a character and an integer. We get both kinds of value. Finally, one shortcut that is very useful to know is that if we add 32 to a capital letter, we get this corresponding lowercase letter. So lowercase character is character. If we take the letter for the capital one and the letter plus 32 for the lowercase one, we get the right result. Similarly, if we subtract the value 32 from a lowercase letter, we get the corresponding uppercase letter. So when we run this, we will see that lowercase capital B is lowercase b. And we're all set. So that is a demo in the last two demonstrations of the arithmetic operators in the C programming language. Thank you very much.